Now at time t equal to t1, that means at first, what we are going to send, we are going to send this message bit, right? So we'll start from this LSB and continuously we are going to going for the MSB part. So 101, this is our message bit that we want to send here. At time t equal to t1, what we'll have to insert this value of 1, that means the LSB, to this shift register. So if I consider this is our shift register, and at first this all values of the shift register is 0. Now what we'll do, we'll take this 1 input and insert this in this shift register at time t equal to t1. So here you can see at time t equal to t1, we are just inserting the LSB of our message signal and we are getting this kind of configuration like 100. And based on our vector diagram, these 3 connections are taken to this modulo 2 adder and these 2 connections are given to this modulo 2 adder. So now what will be our output code word U1? So if I add 1 with 0, then what will happen? 1 plus 0 is 0 and 1 plus 0 is 1, added with 0 will give us 1. So we are getting 1 here. And again, if I add this 1 and 0, it will give 1 also. So this is our output code word 11 for our first message bit 1. Then from time t1 to t2, we'll insert the value of 0 now. So our message bit is 101. We have inserted 1, then we will go for 0 value. So this time transition t1 to t2, it will occur based on the pulses in the circuit. So during the positive peak of the signal, the transition from t1 to t2, it will happen. So now whenever we'll insert this 0 here, the 0 of this position, it will get discarded, and this 1 that was in the previous state, that was in the leftmost side, it will go back to the middle. Okay, so now the combination will be 0 1 0. That means we have inserted this 0 of the message bit here, and for this combination what we will get at U1 is 0 plus 1 is 1 and 1 plus 0 is 1. So we are getting U1 as 1, and what will be our U2? U2 will be 0 plus 0, which is 0 here. The similar thing will happen for T3. That means now in this case, the final 1, it will inserted here. So now the whole process is the similar. 1 plus 0 is 1 and 1 plus 1 will give us 0. And similarly 1 plus 1 is giving 0 here. So we'll get this output. So there is another thing, we have to consider time t4 and t5 also, because of this 101, that means the message bit we have sent 101, we have to add 2 flash bit before this 101 message bit, so that all the message bit they get shifted throughout this shift register. So the number of flashing bit that is required to clean up this shift register will be k minus 1. So the k value that we have said already is the stage, and in this case the k value was 3 and this is 1. So the number of flash bit register will require is 2. That means we'll require 2 zeros before the message signal to send this 101 signal and flash this from the shift register. So from T3 to T4, we have added this extra 0, which is a flash bit, and that 1 from this position, it will discard it and they will shift by 1 position and we'll get this combination. And from this combination, what we'll get, at U1 it will be 1 and U2 it will be 0. Same thing goes for P5. Again we have added another flash bit register, and if I get the output of this modulo 2 adder, we'll get 1 here as U1 and also 1 here as U2. So now if I see the whole code word sequence for M equal to 101, which is our message bit, we'll get code word U equal to first 11, then it will be 10, then 00, then again 10, and then 11. So this will be our code word sequence for our input message bit 101. And notice one thing, that the left side bit 11, this is the bit that is for the message signals LSB. Okay, so this LSB, this represent by this left side bit of the code word. Okay, so now if I go to the lab report, you will see these things they have mentioned here, and the K into K values, the number of shift registers, they mean it by that. And after doing all the things, you will see there is a diagram present here. So this diagram you can easily understand. So in this diagram, the register contents are shown by these 3 bits. So at first you see the bits of the register, they are taken as 0, 0, 0. And in this case, our input sequence is input or message bit is M is 1, 1, 0, 1, 1, 0, 0. So this is our message bit. So at first, what we'll do, we'll just send this 1 to our register, and we'll get like 1, 0, 0. That means the 2 bits, the 1 bits from the rightmost side, it will be discarded, and 1 bit from the input, it will go to the shift register. And as you can see, this register contains 3 bits. That means K into K is equal to 3, right? That means the number of shift register is 3. So we have found this from here. And also this K is equal to 1. That means the number of bits at a time with shift is 1, and the number of stage is 3. And this first 2 bit, they shown the state of the previous or next stage, and the rightmost 2 bit, they represent the state at Ti. That means the present state, it is represented by the last 2 bit, and the next state or the future state, it is represented by these 2 state here, first 2 state here. So at first we are inserting the value 1, and then the shift register, it will just shift by 1 bit and it will become 100. And we can see the states at time t1, it is 00, and at the states at time t plus 1, it is 10. And based on this 100 and also the connection diagram, we'll get our code word sequence 1, 1. So for 100, if I connect like this in a modulo 2 adder, and also this in a modulo 2 adder, for our given connection diagram, you will see we'll get 1 in this part, and in this case we'll get 1. So this is shown here as 1, 1. So for the next case, again we are inserting 1 as our input message, and in this case, what have discarded, the last part of 0, it is discarded, and this 1 is added here. So this is our now register content, and the state at time ti is 10, and the future state is 11. So similarly, if I give the vector diagram and also get the modulo 2 adder, we will get u1 as 0 and u2 is 1. So in this way, whole output we can calculate. So in this case, you can see there is a mistake here. So the 1101 01, and this should be 00. Okay. So here you see the output sequence, it will be 0 0, but mistakenly in the book they have written it as 1. So after doing the input bit or inserting the input bit to the register content continuously and shifting it one by one bit, we'll get this kind of output sequence. So this is our output sequence or the code word that we are talking about, and this code word is for this message bit M. So this is our message bit and this is our output sequence or code word sequence that we want to encode. Okay, so in the next video, I will discuss about the state diagram, and then after that, we'll talk about the tail list diagram.